atmosphere is only 11,000 degrees. That's Fahrenheit. If you prefer Celsius, it's 6,000 Celsius. 11,000 degrees is what we're looking at, but the corona is 4 million. So why? So there's scientific usefulness in studying the corona and prominences that are following the magnetic lines on the sun. Each sunspot is about 5,000 times the intensity of the magnetic field elsewhere on the sun. So we see the plasma, that is broken bits of atoms, that's what plasma is, following because it's channeled by a magnetic field, and we see those prominences sprout like geysers up from the sun. So you bet there's lots of scientific value in a total solar eclipse, but there is no scientific value in a total lunar eclipse. There is close to no value in a annular solar eclipse like the kind we're seeing now. But nonetheless, now we're talking about aesthetic value or
Yeah.
just beauty or how many people will be moved to study astrophysics or astronomy because of the just the sheer beauty of the event today. So we can't say it has no value, right?
Exactly. And one of our feats, I think it's the International Astronomy um, Group, they they're using an H alpha telescope, a hydrogen alpha telescope, which filters out a very specific wavelength of light from the sun. And it's very, very similar actually to SLU's solar telescope. And I kind of introduced in a fairly rushed way at the beginning that SLU has a whole bundle of lovely telescopes that anybody in the world can use. You can watch them all night long. But our main flagship observatory is at the Institute of Astrophysics of the Canary Islands, and that's actually home to some of the largest solar telescopes in the world. But we also introduced, I think 2 years ago now, the SLU solar telescope, which comes online during the day, which is great because it's, while we're waiting for the nighttime telescopes to come online, we get the solar telescope. What kind of features, Bob, can we see using a telescope like that? And maybe not talk about solar cycles. We'll maybe talk about solar cycles a little bit later because there was some interesting news only this week, which maybe we can talk about a little bit later. But what kind of features can we see? Because we will see some of these features, hopefully,
Yes,
through
because
that telescope,
in the white light that we're seeing the
which
sun,
this is, yeah.
yes, which this is and which we normally see, what white means is that all of the colors are mixing together, scrambling together before going into our eyes. White light, it's like a rainbow in a blender. It's like taking the actual emissions of the sun, red, green, blue, and all the rest, putting them in a blender, scrambling them up, and our the human eye's response to it, thanks to the cone-shaped retinal cells that we have, makes us see white. So it's not very useful. It may be pretty, but it doesn't give us much information. So what these SLU telescopes can do using, let's say, H alpha, which you mentioned earlier, is segregate a particular part of the sun's myriad spectral lines and just look at it in the light given off uh, very narrowly. In this case, at 65, 63 angstroms by hydrogen alone when its electron jumps between the third possible energy down to the second possible energy level. And that gives off not just emissions of that deep red color, but shows us specific detail that takes your breath away, shows you prominences and faculae and sunspot details and granulation on the sun and all sorts of wonderful stuff.
And if SLU members haven't checked this out yet, then hop over to one of the SLU clubs, which is our Sun, our local star club, I think, which is where members who love to monitor it in the solar telescope and their own telescopes as well, and they share their images, monitor all of this kind of activity. And it's terrific, some of the animations that they've created of prominent